motion. Now, projectile motion just deals with the motion of something that has been thrown in the air. It will go and come back. The path that a projectile takes is called a trajectory. And that thing that you thrown is what you call a projectile. So we've got basically three types of projectile. Imagine you are standing, you throw something up, and then it comes to, after going, it reaches at that same position, like more where you are the same level where you threw it. It is the first instance. You also have, maybe you are on a building, you throw a stone, it drops down. That is another projectile. Or you are down, you throw a stone, it reaches the top of a building. That's another projectile. So basically, these are the three types. And so let's understand them. So starting with this kind of projectile, you've thrown something, it goes and then it comes back. For this kind of projectile, we take it as symmetric. That means if I cut it on the middle like this part is the same as this part. So that is the first kind of projectile. Now, when I throw something up, I'm going to throw it with a certain velocity. So I'm going to call that as the initial velocity v, or let me just give it v as initial velocity. Okay, let me give it, it's fine, v is okay as initial velocity. Now, if I'm talking about this to be a projectile, it should be at an angle. So there's a certain angle theta at which I've thrown it with respect to the horizontal. The horizontal is a line that is down. Okay, so when something is going up, it will reach this point when it no longer goes up. So this point, the velocity in the y is 0. That's why it can no longer go up. You need to know that this velocity that you've thrown something with is going to be broken in two components. We've got velocity in the x and velocity in the y. Remember, this thing is not just going up, it is also going forward. So there is a component taking it in the forward direction and the component taking it in the upward direction. So velocity in the x is always found by v cos theta. Velocity in the y is found by v sin theta. You need to know again that velocity in the x is always the same for a projectile. So the velocity in the x at this point, at this point, at this point, at this point, at this point is always the same. But velocity in the y differs. That is why velocity in the y at this point is 0. But at this point, velocity in the y is not going to be 0. That is why it is moving up. So the distance from the down to the maximum point there is called the maximum height. The distance from the start of the projectile to the end of the projectile is called the horizontal range. The time taken for this projectile to move from this point, go up, and then come to this point is called the time of flight. Another thing that you need to know is that for you to get the maximum range, you need the angle of the projectile to be 45. Meaning if I throw something at 30 degrees, it might give me like that. If I throw something at 60 degrees, it might go like that at 60. But when I throw something at 45 degrees, it might go like that. So you've seen the range is much bigger for 45. So if you want to get maximum horizontal range, you need to throw something at 45 degrees. From our equations of motion, the first equation of motion we have is v is equal to u plus gt. Hope we remember this equation. V is representing the final velocity. So in this case, I'm talking about vertical motion. The final velocity in vertical means going up. The final velocity in the y or vertically, we can see at the maximum point is 0. So where there is v, I'm going to put 0. And then the initial velocity, which is here, in this case we're talking about in the x, sorry, not in the x but in the y, because we're talking about something going up, that is vertical motion. The initial velocity in the y is given by velocity sin theta, that is the initial velocity sin theta. So where there is u, I'll put v sin theta. Now this g, because we have thrown something going up, it is going against gravity, so gravity is going to be negative, and then t. So I'm going to get this term and take it the other side. It becomes positive gt is equal to v sin theta. And then I'll divide by g. So it is going to be v sin theta over g. So this is a formula that gives you the time it takes for a projectile to move from this point to the maximum point. Now remember, the projectile here is the same as here. So if I know the time to move from here to here, then I also know the time to move from the maximum here to the down. So to find the total time of light, I just need to multiply this equation by a 2. So this is the formula that gives us the total time of light for a projectile. Any question? Any question on that one? Alright. Now another equation that you can be aware of is v is equal to, let's say v squared is equal to u squared plus 2gh. Hope you remember this equation. Now again, I'm talking about the maximum point here. The final velocity is also 0, so this will be 0 is equal to u. This is still talking about height, meaning we are going up. Initial velocity in the y is v sin theta, but remember u was squared, so even this will be squared. And then g is still negative because we are going up, so it will be negative 2gh. I'm going to get this term and take it the other side, so it will be positive 2gh, and then I'll distribute this squared to be v squared, and then sine squared theta. And then to remain with the height, I'm going to divide both sides by 2g, so that will be v squared sine squared theta over 2g. This is the formula that gives us the equation for us to be able to find the maximum height of a projectile. So maximum height depends on the final velocity and also the angle at which you've thrown. I mean the initial velocity of the throw and also the angle at which you've thrown. G is a constant, so we already know that. So another thing that we should be able to know is we have got another equation, which is h is equal to ut plus half at squared. So in this case we are saying h is going to be, now let's talk about horizontal motion. These two we are talking about was vertical, so now horizontal. The initial velocity horizontally, horizontal means moving in the x. So this u we are using is the initial velocity in the x, this u. And that means this formula is not going to talk about h, it will be s, which is distance. Meaning distance is going to be ut plus half gt squared. It is distance because we are going horizontally, otherwise when we are going up we call it height. Now in this case distance we are saying that's the range, so we're going to say r, and that will be equal to u, that's initial velocity in the x, and initial velocity in the x is given by v cos theta, and then multiplied by t. Now any motion going in the x is not affected by gravity, so g is going to be 0, and 0 times this part it will be 0, so that will be out. So range therefore is going to be v cos theta multiplied by time. Now, time, let's put the total time of light, the time it will take for something to move from here up to here, and we can see this is the one. So we're going to put here 2v sin theta divided by g. Therefore, the range is going to be, I'm going to get this v and multiply with this v, that becomes v squared. I'm going to get this cos theta multiplied by a 2 and then multiplied by a sin theta. That is going to give us 2 cos theta sin theta. Now, for now, just tell you that you need to know that 2 cos theta sin theta is the same as sin 2 theta. We are going to understand this when we come to trigonometry. This is an identity you need to know. So where there is 2 cos theta sin theta, I'm going to put sin 2 theta. And then in the denominator we have got g there. I don't know why I wrote theta though. So this is g. So this is the equation that gives us the horizontal range. So these are some equations that you need to know on projectile motion. Is there any question anywhere? None? Okay, so we can check out some, let's do some questions, we see how we're able to work them out. So let's say a ball is thrown up with a velocity of, I'm going to just show what is happening. We throw a ball like that, and we've used a velocity v that is 15 meters per second. Okay, like that. And you've thrown it at an angle of 30 degrees. Okay, like that. So the first question is going to be, what will be the maximum height it will reach if we throw it like that? So to be able to determine the maximum height, we know the equations which we have. If you want, you can use the same equations which we've already derived. If you forget the equations, well, you can still get the formulas. So you know that 2gh is equal to v squared minus u squared. So if we are talking about maximum height reached, so this is going to be 2. G, remember when something is going up, G is going to be negative. And the value for G is 9.8. And then H, and that will be equal to, because we are talking about going up, velocity in the Y is going to be 0 at the maximum point here. Vy is 0. And then minus U. Now U here is the velocity in the Y initially. How do you find velocity in the Y? It is V sin theta. So we're going to say V is what? 15. And then sin, the angle at which you thrown is 30. Remember U is squared, so we're going to square that. So multiply 2 multiplied by negative 9.8 to be negative 19.6, and then H, and that will be equal to, of course 0 will not even write it, so put the negative there, which is here, and then you say 15 sin 30 squared. Okay, just a moment. 15 sin 30 squared. So that is going to give us 56.25. And then here now we want to remain with H. So divide both sides by negative 19.6. Also there negative 19.6. So h is going to be 15.26 divided by 19.6. So that is going to give us about 0.146. This is in meters. So this is the maximum distance that is going to be traveled, or the maximum height the projectile is going to reach. 0.146 meters, which is about 14 centimeters. Do you have questions?
I have a question.
Yes, please.
How come negative 56.25 divided by negative 19.6 give us 0 point?
You are right. How come? You are right. Let me check my calculator. It might be just wrong. Okay, so if you've got a proper calculator, you can just help me punch that. You can help me to punch that if you've got a calculator. Okay, so after punching again, it has given me another value, which is 2.87. So these are some things which happen where you are doing things and then your calculator at times fails you. So we need also to pay attention to the calculator. Passing is not just what's in your brain, also what you are using. Alright, thank you so much for that correction. Anything else? Anything else? Now we have found the maximum height. Let's find the total time of flight for the journey. Time of flight is the time taken to move from this point to that point. How do you find that? We'll say v is equal to u plus gt. Final velocity, first we'll start with reaching the maximum point there. The final velocity at the maximum point is 0. Because I would have used the final velocity here, but I don't know the final velocity at this point. Well, one thing that you should know is that the velocity you throw something with is the velocity is going to hit the ground with, but they are going to have opposite sign, because when it was going against gravity, but when it is coming with gravity. So signs will be opposite, because vectors different directions are going to have different signs but same magnitude. I'm going to use just to the maximum point. So velocity in the y reaching the maximum point is going to be 0. And then initial velocity, this is in the y. Remember, if I'm talking about maximum height, then I'm talking about in the y. That is going to be 15 sin 30. So when something is going up, g is also negative 9.8, and then t. So I'll get this term and take it the other side. That will be 9.8, t being equal to 15 sin 30. To remain with t, it will be 15 sin 30 divided by 9.8. Okay, so we can punch that. 15 sin 30, divide that by 9.8. So that is given 0.765. This one is in seconds, this always in seconds. So that's the time taken to move from this point to the maximum. So if I want the total time of flight, I need to multiply this by 2. So that will give us 1.53. This is the total time of flight for the journey. Any question on that? So they can also ask us to find the horizontal range that the projectile is going to move, what distance is going to cover from there to where it started from. So range, we already derived. Range basically is given by velocity in the x times the time. Or you want to know where it come from, we said s is ut plus half gt squared. This part, because it contains g, to be 0, because in the horizontal g is 0. And then u here is initial velocity in the x, that is why we're using vx. And then you have got the t there, which is the time of flight. So I'll put a velocity index, but velocity index is given by v cos theta, so it will be 15 cos 30. And then that answer we get, we're going to multiply by the time of flight, which is 1.53. So let's see what we're going to find. So that has given me 258.29, which is basically 258.3 meters. So this is how far it is going to go horizontally when you throw at that velocity with that angle of a projector. Do you have questions? All right, let's look at one more question. We are going to have this projector where we throw a stone from this point going up like that, and then it comes and hits the ground like that. So we are going to throw it with a velocity of 20 meters per second at an angle of 25 degrees Celsius. Sorry, not degrees Celsius, but just degrees. And let's say the building is 200 meters. So the first question will be, what will be the maximum height it covers to reach up there? So let me just now write them down. Calculate h, and then the next thing that we are going to calculate is the time of flight. First time to reach the maximum, and then also time to reach. We are going to now say time of flight for c. Okay, like that. We can also say a range, and then the last one, the displacement from the top to the bottom. Okay, so let's answer this. If you've got a calculator, set your calculator with you. Starting with the first one, we want to calculate the maximum height reached h. So to be able to calculate that, one of the equations that we've already used, h is equal to, let me not use this, but 2gh v squared minus u squared. So this is going to be 2. Now going up, g is negative, so that will be negative 9.8, and then h. Find the velocity in the y when something reaches here is 0, minus initial velocity in the y, that is going to be v sin theta, and v is 20 sin 25, and then we're going to square this. So 2 times negative 9.8, that will be negative 19.6h, and that will be equal to, of course, 0, not write it, we'll just write negative 20 sin 25 squared. To remain with h, we'll divide both sides. So this will be negative 20 sin 25 squared divided by negative 19.6. So let's see the maximum height we're going to find there. So 20 sin 25, we square that, then we divide by 19.6 because the negatives are cancelling out. Okay, so that is giving me 0.182 meters. This is the height here. I'll just put it inside 0.182. Now we can find b, which is the time taken to reach the maximum point there. And we'll say v is equal to u plus gt. The final velocity at the maximum point there in the y is 0. Initial velocity in the y is given by velocity sin the angle, which is 25, and then g is negative 9.8, and then t. So I take this portion the other side, it becomes 9.8t being equal to 20 sin 25. So to remain with t, it will be 20 sin 25 divided by 9.8. So t is going to be equal to, let's calculate that. So giving me 0.862 seconds. So this is, I'll put here as t1, 0.862 seconds. Any question? Okay. Since we already know the time taken to move from this point to the maximum point, to find the time of flight, let's first find the time taken to move from here to down, and then we can now add those two times. So how do we calculate that? I can say, so we're now on part C. I can say v is equal to u plus gt. Now, I can't use this formula because I don't know the final velocity at this point. So I can say h is equal to ut plus half gt squared. So the height, therefore I'm going to use the total height since I'm talking about moving from the top here to the bottom here. So this is going to be 200 plus 0.182, and that total height is the one we are going to use here, and that one is going to be 200.182, and that is going to be equal to u, that is the initial speed. Remember, we are at the maximum point here, and that will be the initial speed we are going to take. In the y it is 0, so that will be 0, and 0 times t will still be 0, so I'll just say half gt squared. Now g, because here the projectile is dropping, g is going to be positive 9.8, and then t squared. So this is going to be 200.182 being equal to 2 into 9.8, that will be 4.9, then t squared. We divide both sides by 4.9. So we're going to remain with t squared being equal to 200 divided by 4.9. This is 182. So to be able to remain with 2, square root both sides. So let's see what we're going to find. And this one I'm going to call it to t2. So square root of 200.182 divided by 4.9, so that is 6.39 seconds. So I'm also going to record T2 there as 6.39 seconds. Now remember, we want the total time of flight according to the question. So I found the time taken to move from the top of the building to the maximum, and then from the maximum to the down. So therefore total time of flight will be a sum of those two. Therefore the time of flight is going to be 0.862 plus 6.39. 0.862 plus 6.39, that will be 7.25. Okay, so you people, any question? Any question? Any question? No. All right. So there's another formula that we can use instead of first finding the T1 and then we find T2. We can just use one formula to find direct the time of flight, and that now will give us a quadratic for it will involve the quadratic formula. I can just for you show the formula is h is equal to ut plus half gt squared. Now this h, when you're talking about h, the way we find distance, it is final distance minus initial distance. For example, if you have got this is the ruler, this is reading 2 on the ruler, this is 4, and then you put something like this, you want to find the length of this, you need to say the final, which is 4, minus the initial, which is 2. So this thing is 2 centimeters long. So same with height. To find height, it is height final. So in this case, this is the height. Now when you drop this object, it is going to reach down. So down the velocity is 0, and then the maximum height here, the velocity is 200. So if you say 0, which is the final, minus the initial 200, the answer is going to be negative 200. So therefore the height we're going to use here is negative 200, and that will be equal to initial velocity. Now this is initial velocity in the y, so we'll say v sin theta, that is 20 sin 25, and then multiply by t. Now because the projectile is first going up, g is negative, so this will be negative 1 over 2 multiplied by 9.8 and then t squared. I haven't put a negative here because I'll put a negative here, and then we can work it out. So this will be negative 200 is equal to, let me just see, 20 sin 25, that is 0.845, and then t minus half multiplied by 9.8, that will be 4.9 t squared. I'm going to get this term and this term and take them the other side. So the 4.9 is going to become positive 4.9t, and then this will become negative because it's positive. And then I've got negative 200, that will be equal to 0. So now remember the quadratic formula, x is equal to negative b plus or minus square root of b squared minus 4ac over 2a. So therefore, but here we don't have x, we have got 2t. So t is going to be negative b. So I'm going to put negative. And then b is the term that contains, well, I forgot a squared. This t has got a squared. So b is the term that contains the letter but doesn't contain a square. This is the term. And it is also negative 0.845. Then plus or minus square root the same b, which is negative 0.845 squared minus 4a is 4.9 And then C is the constant, this one which doesn't have t, negative 200. And then everything over 2a. 2a is 4.9. Okay, so t is going to be this negative and this negative, that will give us positive. So this is just going to be 0.845. Then plus or minus, I'm going to work out what is inside the brackets here together with the square root. So I'm going to say square root of negative 0.845 squared minus 4 multiplied by 4.9 multiplied by negative 200. Okay, so we see what we're going to get. So that gives me 62.611, and then that will be divided by, if we multiply 2 by 4.9, we're going to get 9.8. So t is going to be equal to, now if I say this one minus this one, the answer is going to be negative because we're subtracting a small number minus a big number. So I'm just going to use plus because time should always be positive. So I'll say 62.611 plus, so that will be plus 0.845, and then the answer that we get, I have just, okay, let me just repunch that. 0.845 plus 62.611, the answer we get will divide it by 9.8. My calculator is quite trick, so it's a bit difficult to punch. Let me just write that again. 0.845 plus 62.611, then divided by 9.8. So it has given me 6.475 seconds. So this time is supposed to be the same as the total time of flight here. Now, because the confusion of the calculator I'm using, it is just on the phone, pressing the sign and these other things are a bit trick. So you can just try to confirm at your own time, punching it right on the calculator. Perhaps I've just punched it wrongly, but the answer this time of flight is going to be the same as this one. So now that I've found two, I don't know even which one I'm going to use for the other questions which need time of flight. But let's use this one. I'll take it that there's just an error in this one. Otherwise, and the second one is even much simpler. We're going to see to reduce on your time, but the first one is very much better also. So it depends with what you want. You can always try out both to make sure that you don't lose out any mark. Now this one is saying calculate the range. When you're calculating the range, remember range is just given by vxt. Velocity in the x is found by v cos theta. V is 20, cos the angle theta 25. And then the time of flight, that's the one we are using, 7.25. So let's see, 20 cos 25, then multiplied by 7.25. So the range is giving me 131.411. 14, I mean, meters. So this is the horizontal range, the distance traveled down here. Now the other question is saying find the displacement from the top. Now remember, displacement is just the shortest distance between 2 points. So this question can also come as find the direct distance from the top to where the projectile hits the ground. So the direct distance is this one, or the displacement. So to find that, we can see that this is the hypotenuse. We just need to find this squared and then the range squared. This is a triangle. Use the Pythagoras theorem. So the direct distance or the displacement, let me call it h, is going to be the square root of 200 squared plus the range, which is in this case we found at 1.1.131.41 squared. So if you work out this, the answer you find, that's the direct distance or the displacement from the top to the bottom.